Welcome. We want to take a look at an example of plotting an exponential function. You've already seen a little bit of plotting exponential functions. So for example, we've already plotted 2 to the x, and we found it to look something like this. And we just want to recognize that our manipulations are going to be the same thing, shifted left, right, up, down, that sort of thing. All right, 2 to the 0 is equal to 1. So kind of our base case or standard for all exponential functions, no matter what the base is that it crosses the y-axis at 1. And that's really the intercept that we're interested in, is the y-intercept. So here I say any intercept, but really we're interested in the y-intercept specifically. So the y-intercept is given where x is equal to 0. So let x be equal to 0. That, of course, is just f of 0 then. And so we have 2 to the 0 minus 3. So we see that this is equal to 1 minus 3, which is negative 2. So we see where it was at 1, it moved it down by 3. So that's going to give us, now we also have that it approaches this horizontal asymptote of y equals 0. So it's shifting everything down by 3. Again, we're identifying that by taking a look at the y-intercept here. So if we want to plot this, it doesn't have to be anything fantastic, nothing great. We just want to recognize that we're kind of shifting everything down by 3. And so we get this horizontal asymptote at negative 3 instead of 0. So y is equal to negative 3 instead of y equal to 0. And our function will grow in this way. Now, is that perfect? No, we really could evaluate at more places and provide a much more precise graph. But this is the basic idea. If you would like to evaluate at a few places, that would certainly be a good idea. In fact, yeah, we would know that it would cross here, here, and then actually up here, I do believe. So it would be even quite a bit steeper than what I've drawn. Anyway, sufficient. It gives the right idea, and that's primarily what we're looking for. If we consider subtracting 1 in the exponent instead of 3 outside of the exponent, we can find that y-intercept again by letting x be equal to 0. So f of 0 is equal to 2 to the 0 minus 1, which is 2 to the negative first. We can think of that as 1 over 2 to the first, or simply 1/2. Now, if we consider the original function, when we evaluate at 0, it would be 2 to the 0, and it's become 2 to the negative first, right? So where x was equal to 0, we are now moving that over. I'm sorry, where it was equal to 2 to the negative first, where it was 1/2, we're moving that over. So if I draw kind of the here it crosses at 1. If I draw this over here at negative 1, it should be 1/2. And what we're doing is we're kind of moving this over that direction. So we're moving it to the right just a little bit. So our horizontal asymptote won't change because we're shifting to the right and to the left. Now, there is a whole section on translating graphs. We're not interested in covering that, just a couple of basic ideas here. So I'm going to plot my y-intercept as well as the horizontal asymptote and just kind of draw it in a way that makes sense. So our horizontal asymptote is still our usual here, but now our y-intercept occurs here, and we should have points that look something like this. So it's pretty low, increasing very slowly, and then all of a sudden starting to increase very rapidly. And that gives us the right idea. If we combine these two things together, essentially what we're doing is we're moving the graph down by 3 and to the right by 1. I think I said to the left earlier, so I apologize about that. We'd be moving it to the right. So we end up with a y-intercept where we let x be equal to 0. F of 0 is equal to 2 to the 0 minus 1 minus 3. So that's 1/2 minus 3. 1/2 minus 6/2 is a negative 5/2. And we still have a horizontal asymptote of y equals negative 3 because we're taking everything and moving it down by 3. So I can plot those. So negative 5/2, negative 2.5 would occur here. Horizontal asymptote of y equals negative 3. And I would get additional points that look like this. There we go. And connect the dots in a way that makes sense. If you're curious about how I get these other dots, I know what it's supposed to look like, so I can identify them quickly. It would be a good idea to evaluate at 1, 2, 3, and 4 to give yourself an idea of where those points are. But again, we're mostly interested in just taking a look at rough sketches, so that way we have an idea of what the exponential function looks like. So that's sufficient for now.